Because of the advances in various telescopes and because of various new surveys out there, the scientists have been actually making so many groundbreaking discoveries in just the last few years. And many of these discoveries are coming from our neighborhood, right here from the Milky Way, not so far from planet Earth. It's always been there, it's always been visible to us, but up until recently, we didn't really know what we were looking at. And in this video, we're going to be discussing this new discovery of two intriguing white dwarfs, relatively close to planet Earth once again, that have been recently discovered to possess very unusual properties, but more intriguingly, seem to possess signs of the oldest planets we've discovered to date, the oldest planets at least in the Milky Way galaxy. Hello info person, this is Anton, and so today we're going to be discussing this relatively new study that as always you can find in the description below, that use some of the most recent observations from the Gaia telescope, from the Dark Energy Survey, and from the European Southern Observatory, combining them into one study that makes these two white dwarfs, at the moment, some of the most exciting white dwarfs we've ever discovered. But before we talk about the discovery, a brief review about what these white dwarfs represent. This is essentially the future of the solar system. We know that around 97% of all of the stars in the Milky Way at some point are going to become white dwarfs, and that's of course including our own sun. But they're probably going to take slightly different paths, and not all of them are going to produce what's known as planetary nebula. Our sun though, and a lot of other similar stars that are even more massive, up to about 10 solar masses in total, are going to eventually get really old, start producing a lot of winds and start to expand even more, and eventually leave behind a shell we usually refer to as a planetary nebula. There are quite a lot of beautiful ones out there we've discussed in previous videos. But right in the middle, there's going to be a leftover. The core of the star, also known as the white dwarf. The object that's extremely dense, only about the size of planet Earth, but usually possessing up to 1.4 solar masses in total, with the nearby Sirius B being the closest neighbor we have that has quite a lot of mass and is a white dwarf orbiting a partner known as Sirius A. This beautiful picture from Hubble telescope right here shows us both of these objects, and you can see that the white dwarf is actually really tiny in comparison. But as I mentioned, quite a lot of stars, including more massive stars, are going to become these objects. And some stars that have up to about 10 solar masses are going to go through their stages really quickly, possibly in just a few 100 million years, and turn into white dwarfs extremely fast as well. And so some of the oldest stars in the universe have already become white dwarfs that have been in existence for a pretty long time. Now the scientists have already discovered thousands and thousands of white dwarfs out there, but some of them seem to be really strange. Okay, white dwarfs are already pretty strange. I mean, by itself, this is really unusual matter, known as degenerate matter, that's essentially a kind of an ocean of electrons. But these two recently discovered white dwarfs are particularly strange. First of all, they were actually some of the coolest white dwarfs we've discovered. Coolest as in temperature cool. They were about 3000 Kelvin, which is much lower than a typical white dwarf, and is actually much lower than the sun. In this case, the temperature is a lot closer to a typical red dwarf. But more intriguingly was actually the color that they were producing. One of them was somewhat blue, but one of them was somewhat red. And it's this unusual coloration and the temperature that hinted at something weird going on around these objects. And so the scientists decided to analyze them using spectroscopy by using ESO's, or European Southern Observatory's X-Shooter instrument that's able to produce super accurate spectroscopic observations. A typical image looks something like this. It's actually kind of beautiful. But what's important here is that it then shows us what sort of elements contained inside the light coming from various stars or from various objects, allowing us to determine the composition of most objects we're looking at. And so in this case, they analyzed both of these objects, discovering that first of all, they were quite different, but more importantly, both of them were basically polluted white dwarfs. Polluted in the sense that they were both absorbing a lot of matter, a lot of gas, a lot of different materials, very likely with a large accretion disk like you see right here, with all of this then mixing on the surface and then directly affecting the atmospheric composition of the white dwarf. Yeah, the white dwarfs, they also have a bit of an atmosphere. But normally this atmosphere is pure helium, but in this case it wasn't. In one of the white dwarfs, it was a mixture of helium, sodium, calcium, lithium, potassium, and potentially something else, including carbon, which turned the white dwarf more red. And all of this stuff, very likely, almost certainly, came from the old planetary system that most likely survived the times when the star turned into a red giant and absorbed a lot of the other planets, which is probably what's going to happen to planet Earth sometime in the future. But as these planets survived, they slowly moved closer, and at some point the white dwarf possibly shredded them and started to absorb them onto its surface. But because in this case it was discovered that this white dwarf is approximately 10.7 billion years old, it means that these were the oldest planets in the Milky Way discovered so far. Okay, I guess not actual planets, more like planetary leftovers, but they were very likely planets up until recently, until the white dwarf shredded them apart and turned them into some kind of a disk. And the elemental presence around this white dwarf suggests that these planets were probably very different from anything we have in the solar system, which does kind of make sense because we believe that early planets were probably much different. Back then the universe was still kind of low in a lot of heavier metals and a lot of heavier materials, and for the most part had quite a lot of hydrogen, helium, lithium, and lighter materials, which of course implies that these planets were probably very different from anything we have here in the solar system, or actually in any of the other star systems that are much younger. Now we obviously have no idea what these planets would look like, or if they were terrestrial, if they had surfaces, or if they were just unusual gas giants, but they were clearly there, and the signs of them now being absorbed are also there as well. Chances are further investigations and analysis of this particular star is going to reveal more and potentially even discover what these planets were like. Since this is only about 90 light years away from us, it's one of the closest objects to us, it's going to be quite possible with modern instruments. But then there's also the question of the second white dwarf, the one that's not red, the one that's a little bit more blue. It's slightly farther away at approximately 120 light years away from us, and it's also a little bit younger at maybe just over 9 billion years to maybe almost 10 billion years old, but it's clearly also polluted, very likely absorbing planets as well. But in this case the pollution is very different. Here the analysis of spectroscopy determined that these planets were extremely Earth-like in terms of the debris that was depositing on top of the white dwarf. It actually kind of resembled Earth's continental crust. And that of course makes it super exciting and somewhat unusual. It does imply that maybe back then Earth-like planets did exist as well, even though technically we kind of think that planets were probably much different. And so it's really the observations of the unusual mixture of helium with a lot of other elements that the scientists so far were able to work out that these were definitely planets, and one of them, or maybe even several of them, were potentially terrestrial and maybe even Earth-like. But also, with all of this disappearing nearly 10 billion years ago, which of course implies that these planets, if they did exist, could not have existed for more than about 3 billion years. And really at this point anything else is just going to be speculation. Any kind of life, any kind of terrestrial conditions, none of this we can answer yet. But because 97% of all of the stars in the Milky Way galaxy are going to at some point become this, by performing more analysis and by performing more observations, at some point the scientists might actually come up with various models for what sort of planets create what sort of pollution on different types of white dwarfs in different regions of the Milky Way, allowing us to maybe one day reconstruct some of these planets in terms of models and obviously find out what sort of composition and what sort of properties they must have had. But just the fact that these planets existed 10 billion years ago, with Earth itself only being 4.5 billion years, is already pretty incredible, and also provides important evidence for the existence of planets early on, and for the existence of planets most likely everywhere in the Milky Way galaxy. But also existence of Earth-like planets around stars that are not so different from our own Sun. Well, actually a little bit more massive, but not so different otherwise. Although that's not really entirely true for that red white dwarf, the one that's closer to us. Here the planets are a little bit more mysterious. Because of the presence of lithium and potassium, and actually huge amounts of those elements, if this is coming from planets, and it probably is coming from planets, it's unknown what sort of planets they were. It would be completely different from anything we have in the solar system, or anything we can even imagine. Now one explanation here could be that it's coming from brown dwarfs, or a brown dwarf that used to exist here, but that's just a speculation, no proof just yet. Brown dwarfs are known to possess quite a lot of lithium. But I'm sure we'll be hearing more about this white dwarf, this particular white dwarf that's about 90 light years away from us, because it does seem to be a little bit different from anything we've seen. It's also extremely magnetic, super red compared to anything else, and the oldest white dwarf we've discovered so far with the lowest temperature, and also obviously planets. And so once the scientists discover something else about this unusual object, or maybe even find out what sort of planets existed here, I'll make sure to follow this up with the next video. Until then, thank you for watching, subscribe, check out all of the relevant links in the description below, maybe support this channel on Patreon by joining channel membership or by buying the wonderful person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.